Go!
Hello everyone, welcome to Practical GCP. Today I would like to talk about a near real-time CDC solution using a Google service called Datastream. So this is about replicating change data from Cloud SQL to BigQuery in almost near real time. But before we jump into the detail of the solution, I think everyone must be aware the current way. So I think there's still lots of use cases we may need to use this solution. But this is probably one of the common ones where you get data using a schedule, such as you have Airflow cluster running in the middle, where you run DAX, and you have the databases on the left, where are your source systems, such as Postgres or MySQL. It's typically using a scheduled pool, either daily or hourly, to get that data into BigQuery, right? So the solution in the middle, typically you point to an individual table, right? And then using a select query plus a where clause where you do delta tracking, which typically using the timestamp updated, sometimes even combined with the timestamp created that is greater than or equals to execution date, which in a daily kind of ingestion scenario, this points to the day before. So you kind of capture the change, right? That's kind of, we can call it old ways, this is talking about specifically from relational databases, right? And I would like to cover a little bit about from my opinion, what actually been happening in the last few years. So you probably heard about solutions such as Fivetran, Illuma, and Stream. So those are the three, in my opinion, the mainstream solutions in the last 3 to 4 years that's been focusing on CDC, which is called the near real-time change data capturing solution, to get data typically into a cloud-based analytical databases, just such as you have BigQuery, you have Snowflake, you have AWS Redshift. So these has been the databases where people trying to get data from relational databases into right. So then you can really kind of unlock your analytical use cases on the right hand side using the cloud. So in the past few years, these are the mainstream solutions have been focusing on, including Illuma has been, I believe, bought by Google in 2020, right? So that's where, I can take a guess, that's probably where Datastream kind of initially got started. Right now, it has been through 1 or 2 years of development, which is a lot more powerful, which is what I'm going to be specifically talking about with the Datastream solution today. So let's talk a bit about the change data capturing solution. So the way this works, in a nutshell, you can see is kind of the change data capture is not using SQL, right? So this is one of the biggest differences. It's not that you run a query to try to pull data in that traditional way. So instead, so this goes back to about database replications from 30 years, if not more, ago. So let's use the example of MySQL. So in MySQL, there are things like common database activities such as schema change, insert, update, or delete. There are other things I probably haven't covered, but these are the most common ones, right? So when these things happen, it generates something called a binary log, right, or transaction log. So these things can be used for typically database replication. So you have master database, you have read replica, or called slave databases. So those are the databases you can actually use to scale your systems. So if you have a web app or if you have an application that is has a lot heavy load at peak times, typically you don't want to run all of these heavy queries on the master database because that could affect things like updates, inserts, and delete. So the read replicas are typically created for maybe some reporting, maybe some heavy queries that can take a little bit longer, but it would not affect the operation of the master database, which is where you run these people call it CRUD applications, right, from the websites. So those exact binary logs used for database replications is the core essence of what these CDC solutions has been designed to work with. So MySQL is just one of the examples here, but the way it works is it will read those binary logs sequentially, right? You can see every time there's a change made, let's say if I insert a row, I update a row, then I delete a row, then I insert a few more rows, and a few more rows again, right? So every single time that single row is replicated as action. So if it's an update, it will be replicated to that latest version of the updated row, right, as a line of binary log. Then that's going to be used through the CDC engine or the solution into, in this particular case, where the majority of the data capture solution is going to be appending those, right, into those target analytical database. So in BigQuery scenario, it will be using streaming insert to append the records. So don't worry too much about it. I'll cover the exact use cases and I'll show you examples and a demo so you can see exactly how this thing works, right? Let's have a look at the Datastream CDC solution in detail. So if you look at this design, it's very similar to the previous diagram. On the left-hand side, you've got the database. I have used the Cloud SQL database that runs MySQL, right? So this is just for convenience, so I can create this from scratch to show you an end-to-end working solution. But keep in mind, the Datastream solution is not limited to just work with Cloud SQL. It can work with RDS database on AWS, the Azure databases, or anything on-prem, as long as you have connectivity either through a VPN pipe or interconnect, right? But don't expose it publicly. So that's the database kind of on the left. If you look at the top and then going to the right, so you typically for MySQL expose a port at 3306. This is how you usually connect to it to query as well, which is how you use to access the binary log. This is the application, with a single database, maybe a few tables. The next bit is, in order to connect Datastream into Cloud SQL, right? You cannot do that directly. I'll come back to explain that in a little bit, but let's go through the whole solution first. So you would need a TCP proxy, right, to forward the request, the connectivity request, but because you cannot connect to it directly. And once you've got the TCP proxy set up, then Datastream is able to gain connectivity via the proxy into the Cloud SQL database, whereas the binary log can be accessed. That database would basically does its thing, and then automatically create the table and then start replicating the data. This is what happens on the right hand side. On the bottom side, because if you think about this, right, so the way CDC solution works is that it is designed to replicate events. Those are the events that are generated, as I mentioned, based on insert, update, delete, and some schema changes, which are, typically from the time that when you made the connection. Let's say you already have a database with 3 tables that has gigabytes of data, or tens of gigabytes of data already there. So the CDC solution is designed to, at that point, right, replicate any changes captured onwards into BigQuery, right? So the things that you will still have, that is the historical data sits in there, which in this case, Datastream can deal with it, but I think probably the best idea is to have your own version of it, right, rather than rely on this solution, because this is connected to the master database. You probably don't want to do the snapshotting, all of that one-off load on a master database, because it can affect the system operations. As I mentioned earlier, the replication, via the CDC process is using the binary logs. So which is exactly the same as how it used to do the database replication to create the read replica. So if you have the read replica, what you can do is to have an Airflow job, to have an on-demand trigger to basically, grab the whole table from the read replica, which would not affect the normal database operations, chat those files into cloud storage as, for example, JSON lines, gzipped, and then loads them into separate tables, right? So keep in mind, those database tables replicated with append only via the Datastream event stream. These are append only, or every single rows of the latest changes, right? So those does not contain historical data. But what you can do is, once you've done these to both parts, you can combine them via authorized view, which you can expose to users exactly the near real time, which you're talking about minutes, right? Or even seconds, depending on how you configure the data stream pipe. then the user would gain near real-time data access, right? So compared to the traditional solution, this is a near real-time in the last couple of minutes or even shorter for the access to the data. So this is not like a daily batch or hourly batch. It's very different kind of solution, right? So this is the whole solution in a nutshell. I want to spend a bit more time talking about this proxy here itself. So there's article I'll recommend, which is the one I read because I did a lot of research. It was not easy. It wasn't very well documented because this thing is still in a public preview, the Datastream CDC solution with BigQuery. So I read another article that someone did the same thing, that had the same problem. So it's not very obvious that you cannot directly connect Datastream into Cloud SQL. The reason being where Cloud SQL and where Datastream runs. So both of those services do not run in your own VPC, right? So keep those in mind. Both Datastream and Cloud SQL runs on the Google service, right? On the Google project that belongs to Google, and they run all of that stuff, and then including all of the operations, and then they use VPC peering to peer with your VPC, right? So the network is on your end, but actually they expose the IPs privately to you, and then the service privately to you, but the actual service for both Cloud SQL and Datastream runs on the Google side, right? There's no direct connectivity. You can expose the decider ranges to each other, right? That's not going to happen. So for example, the Cloud SQL range where the service is deployed is not visible to Datastream. And as far as I know, there is no way to expose that directly. But what you can do instead is, because if you have any service, right, that originate from your own VPC network, for example, in this case, the proxy is deployed on a compute engine in your VPC network, and then you can actually connect to both sides, right? You can connect to using the proxy to connect to the Cloud SQL database. So then this IP range now can be exposed to Datastream via a firewall lift, right? So Datastream can actually now see this, the compute engine IP range, and because compute engine runs the TCP proxy to forward port 3306, basically runs on the original Cloud SQL service to access the binary log, then this whole thing connects, right? So it's quite complex, but the source code is actually working, exactly does this, right? It's all automated, so you can actually try this out yourself. It shouldn't have any problems. So, but let's have a look at the setup. So this is the repository where I think I've detailed it quite a lot on how this actually works. So as an example, to get data from MySQL to BigQuery via the Cloud SQL host. So this is done in Terraform. So before I walk into the detail, I just want you to have a look at this article, right? Which is where I learned from Marvin, this guy. He ran into the same issue. So you can see he explained more the details around the how you can get started creating the network, the proxy server, and how this all connect together. There's a Terraform code in here as well. There's also creating the database itself, creating a private connection. So it's all here, right? So if any of the things I explained is not covered in here, it's because it's already covered in here. So it's not much point duplicating it. This is already very good. So I did make a few changes. So you can see there's a few things I made the changes in the bottom, which is just additions to make this completely private, and also some of the binary log wasn't or not enabled by default. But yeah, and also I'm not using the default network in my use case, and using the default network isn't as far as not following best practice, because you don't really want all of that network in different regions, that all of the IP ranges that isn't really fit into your IP capacity planning configuration. So in most, especially larger companies, you would not see the default network on your VPC. So this is if you create your own network, and then you can use this script I've modified to fit better into your customized network, right? So in your VPC. So, but that's just I've created a link in there, and then this is the repo in here as well with Terraform code, very similar to mine. But that's, if you see anything that is different, you can always check out the original one, right? So there's few things I've done in there, and in this Terraform code, it creates the MySQL database on Cloud SQL. It sets up the private connection profile to Datastream connected to the VPC network. So this is you need this in order to connect to the MySQL database, right? So that's called the connection profile. And then this bit is the compute instance where you need a SQL proxy to bridge the traffic because it's not directly accessible between Cloud SQL and Datastream, right? And then finally, just remember, after you run the Terraform script, you just need to do Terraform init and Terraform plan in this directory, and then you see what it's going to do. And then for anything that you want to change, you can change it in the variables to use your values. This is just the one I'm using on my end. And then the rest is all in main.tf, right? You can see all of this stuff. At the very end, this is the thing I was mentioning about the proxy. So this is a Google hosted image for Cloud SQL proxy. So all it does is it gets this. This is why it needs CloudNet, because it's trying to get it from the internet, right? So that I've added CloudNet in this particular case to allow you to fetch the image. But I think ideally, you probably want to package this as an image, as a Docker image, where you can deploy this in a container instead, so you don't actually need the internet access. But all it's doing here, you can see, is getting the Cloud SQL instance connectivity name, and then does the forwarding to port 3306, right? That's the TCP proxy. And so right, that's, this, if you run this, and this will set up all the things that I mentioned in here, which will allow you to do the connectivity end to end, right? Now let me show you what I've actually set up. Right, so to start with, if you look at the SQL instance, this is the one I've created on the private network. As you can see, there's no public IP. This binary log on this instance has been enabled, and you can see on the user side, I've created the Datastream user and the root user, right? The Datastream user is created directly on the MySQL database. So this is this does not have like root access, right? But the root one is the one you use to log in to create the Datastream user. A backup must be turned on. This is already done as part of the Terraform script. So this is required in order to do so you can see the binary logs is there that retained for 7 days, right? So that's what it's using to do the CDC replication. So and then this one, as you can see, is the Datastream proxy that I've created in the private network. This is where the TCP proxy runs to forward the port on 3306 on the traffic. The Bastion host I have in here, you can have a look at another video I've got about how to use the Google proxy, the IAP, to connect to your Cloud SQL database privately that doesn't have a public IP. So this is all set up very securely, so you don't actually need anything public to set these things up. Right, and here you have the Datastream section. This is where you create the peering with the Google network, where you can actually put connection profiles to run Datastream. So if you look at this, right, so you've got the profile already using active, but the profile is actually created in here. So you've got one, which is the MySQL profile, and if you've got one, which is the BigQuery profile, right? You have the source, and then you have the target. That's the kind of how the replication goes. So if you look into the details of this, right, let's go to edit so I can show you some of these sections. So you can see here, when you set up the connection details, you can see I've set it up to 15.207. So this is now the Cloud SQL database, which starts with 172. So this one is the 15.207. This is the proxy. This is the virtual machine, right? And then you set up the port 3306 with username and password. This is the Datastream username and password you've set up. And if you look at the connection, so this one I've just done it for convenience, so I didn't include any certificates, but you can exclude all of the certificate and private keys from your Cloud SQL database. So you just need to download them from Cloud SQL and upload them to here, so you can actually make sure the traffic on both sides is encrypted. The connectivity method in here, it uses, so make sure you select the private connectivity pairing. So the VPC peering, because the first two, right, all require public there's something to the IPs, to public IPs, which expose this whole thing outside of your private network, which is not ideal at all, right? So you want to use the private connectivity. This is why you use the TCP proxy. So it's everything keeps on private. You pair with the Google VPC, and then we're all connected, right? So and this is the thing I mentioned earlier. This is the Datastream connection. This is the peering part. So now we've created a peering part, so Google knows on which IP range, the CIDR range, they can deploy the Datastream service to, right? So that this is where the IP that's where it's exposed to. Once you've done it, you can run the test, right? You can see this now connects, right? So this test pass. But if you don't set up the proxy, the TCP proxy, this is not going to work, right? You can try it, but I do not know any other ways to get around that. So that's the main bit, right? Is the setup for the MySQL profile. The BigQuery process is very straightforward. There's not much you need to do about there. You just need to create it, and then it knows like the BigQuery side. But when you actually create the setting it up on the destination, it will also ask you to set up the the data set, the prefix, and where you want your data to go. So that's pretty much it, right? So now you have the streams. After you set up all of these profiles, you can create a stream. So this stream is basically the Datastream job. So now you can see this is running, and if I click on edit, I can click edit the stream settings, the source configuration. You see this is all here, right? So the source configuration, you have a bunch of selections. So you can see this is kind of connecting to the database I've created. So I've created two tables in here with the customer and transactions. This is where you can choose exactly what you want to replicate. You probably don't want to replicate the information schema and the system configurations. That's not very useful, but these are your relational database tables where you want to replicate. You can set up a few rules and also the backfill mode for historical stuff. So this is where I suggested I would probably not use this one. It's just because it's connected to the master database. So I've got the separate design in there, which I would prefer to use the Airflow job to pull the historical data one off, which you can also use as a disaster recovery process, because sometimes the replication log or the binary logs do break when the database is corrupted. So when that happens, you would typically need to restore a database backup, but then at that point, your binary log is gonna be broken, right? You need to set up the whole process again, then the event stream starts again. But that disaster recovery process, to recover the CDC process, obviously you need to reload all of your historical data again into BigQuery, right? So then everything kind of will catch up again. So right, so that's the things you can do on the configurations. Here you can have a bunch of useful information on the monitoring, where you can see how data refreshes works and what's the latency like, how many events has been processed, the monitoring of, if you look at the last 6 hours or so, you can see this, there's the throughput, the unsupported events. Here you also have the data freshness and the latencies, and so on, right? So this is all based on how you configure it. And here you can see the objects. You've got these two things, which are the two tables I've created. So here you got the option to initiate backfill, which I think you should do this very carefully, because if your database is very busy, this may cause problems. But you can see the details here, which you can see the schema of your database. So this is very handy, right? So it's all connected. And on the BigQuery side, so you can see this is actually the replicated customer events, right? This is not the customer table as of the latest customer table. Is all of the captured changes, the events that have been replicated in streaming inserts as append only, right, into this table. So you can see I've been playing around for a bit already. In the schema, you can see you've got the 3 columns: ID, name, and email, with some metadata, but then you can see this new column is something actually appeared after the Datastream metadata, and this means it also handles changes of the schema. So this is one of the very difficult things in many solutions, because if you have a batch schema that you usually, if your database has a new column being added, then it can be a manual process, right? But this is actually automatic. And if you look at the preview, you can see what actually happened was I've created a lot of records in here, right? And then initially you can see all of these things are null on the new column, but I do have all of the other columns, right? So this is not particularly ordered very well, but it starts from, you know, ID 1. This is the auto increment ID, and then every single change has been captured, right? There's two very useful columns in here, right? So just keep those in mind. One is the UUID. So this one, so that's you can see these are all unique, right? So these are the unique UUID for I believe every single change that's been captured, and this is the source timestamp that exists in the binary log, right? This is very accurate on exactly, you know, when something has been changed. So this is something that is very important for you to keep in mind, because you're gonna need this, right, to wrap up the data, right? If you have something that's been changed a couple of times, and using this one, you would know which one is the latest, right? So that's the timestamp that you can use to achieve this kind of things. You can see the adding new column behavior in this particular case is when I've added a new column, and this new column in this case, initially it backfilled all of the existing one to be null because it added a new column in the schema, and then you've got number 0, number 1, which is what the change I've made on the other side, right? So this is very interesting, because let me show you something that I could do in here. So this is the actual table I've got. So what I can actually do is, let's say I'll just duplicate these columns, you know, a few more times, and then start filling in, you know, just a bit higher numbers in here. You see, and then maybe do a bit 100 here, and then change this to 10, right? So, and then if I commit this, so as this goes in, this is going to start replicating on the other side. I didn't configure the insert on this side to be you know, very low latency, so it might take a bit of time for this to come through, but let's have a look. All right, let's come back and go to the last page, and there you go. You can see that, there you go, right? That's all the things I've just added with all of these new values. You can see the timestamps are the ones that, you know, happen here with all of these different columns, right? That's different values. You know, you can compare the two, right? And now I can make some changes to this one as well. I can change it to 11, commit, change to 12, commit, right? Change to 13 and commit. And let's see what happens on the other side. So there you go. You can see that the 10 and 12 and 13, 11, right? These all have different timestamps and different UUIDs. So you can see, so when you need to work out the latest version later on in the authorized view, which you need to use such as a window, if you want the latest version of this row, right, based on this primary key, then you need to wrap it up using a window function such as row number. Then you're going to need something to sort your to do a rank, right, to sort your data, and then this would be the column you can use. You can see these are all the different timestamps, and then they're very granular, right? Then you can see this is the latest. So just to do a bit of summary, so in my opinion, Datastream, although the BigQuery CDC solution is actually quite new and still in still in public preview, but I think this is mostly ready as a Google Cloud native solution. So the other solutions such as the other three I've mentioned, they're a lot more mature. So Google is still quite catching up in this space. But if you are looking after a native solution in Google Cloud that is supporting this kind of stuff for a number of databases, and Datastream could be the one that you want to consider, because it's quite easy to set up, and it doesn't require you to buy something external to deal with this stuff. And make sure the TCP proxy is set up properly, because otherwise it won't work. And also, as I mentioned, it's probably worth not having the outbound internet access, because you don't really need it for the replication process. But then package your proxy as a Docker container, then deploy that instead. I think from my perspective, I would use a separate process to manage the one-off load for the historical data, just because it's a little bit dangerous to connect that to the master database, right? Because that usually is the very busy one, and then you don't really want to just let a application that without a control to basically press a button, you can just do a full reload from your database. That is quite a bit dangerous, I think. Obviously, use your author IVs to present your data. You can use the historical data on the left, your real-time events on the right. Do a row number, wrap up that based on the event source timestamp, and then that's going to give you the latest version of every table combined. If you want to save a bit of cost, if you have so much events every day, then you can also wrap it up, once a day or once a week, using a batch process to, rather where you run your row number, that function, rather than doing that just with all of the events and historical data, 3 months out of date. You can actually wrap your real-time events into a snapshot on a daily basis or probably weekly basis, and then you can have the near real-time access to the data, but also not gonna cost you too much, because you're not going to need to row number wrap up all of the events of all time, right? You're just dealing with the last 7 days, last 14 days, whichever date range you prefer. Okay, that's the end of the session. It's quite a long one, so but I think it's worth exploring, and to start thinking about really using one of the CDC solutions, and especially if you're on Google Cloud, look into the Datastream one to replace your boring ingestion, one table at a time solution. So this has been a lot more mature in the last few years. Many companies are using this kind of solution now. So yeah, look into it. So hopefully this is useful. I'll see you next time.
Go out!